Okay, so there's three possible answers. It doesn't matter if you change your guess. You should, and you shouldn't. You have to vote. This is not like the American elective democracy. Mandatory, okay? Who thinks it doesn't matter? It doesn't matter if you change your vote. You'll win about the same amount of times. 2 people? Who thinks you should change your guess? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So who thinks you shouldn't change your guess? Who thinks you shouldn't? Something like that? Okay, so the majority thinks you should change your guess. That is correct. You should. Anybody want to guess or anybody know you increase your chances of winning by how much if you change your guess?
Twice.
You change it by twice? What does that mean?
You have twice as
Yeah.
chance to win.
You have double the chance to win. That is correct. You increase your chance of winning by 100%. 100, and that's what I'm going to explain. Better chance of winning. What that means practically, just numerically, everybody, if you played this game 100 times and you didn't change your guess, how many times could you about expect to win if you played it 100 times? 33 times. You'd win about 1/3 of the time. If you switch your guess every single time, you know how many times you're going to win? About 66 times. 66, 67. You'll see. Ready? Okay, so the way you think about this, think about it in terms of this way. I'm going to write it a little better than that. First guess correct. What are the chances your first guess is correct? 1 out of 3. First guess wrong. What's the chances of that? 2/3. So if you just played this game straight through, no changing, no nothing, your average chance of winning is 1 out of 3. Your average chance of losing is what? 2 out of 3. Got it? Okay. So now we're going to think about it is if we switch. If your first guess is correct and you switch your guess, what does that mean about the result of the game? You'll always lose. If your first guess is correct and you switch, you'll always lose. Do you agree with that? There's no other way to win. The win condition is singular. If your first guess is wrong, what happens when you change your guess? You always win. Do you agree? If you originally guess a wrong door and you change your guess, you always win, correct? What are the chances? So do you agree that these are the same? You will always lose if you change your guess and the first guess is correct, and you will always win if you change your guess if you were wrong. Do you agree with that? What are the chances that your first guess was correct? What are the chances that your first guess is wrong? What's your chance of winning if you always switch your guess? The only way to win if you switch your guess is if you originally chose a wrong answer, right? What's the chance of originally choosing a wrong answer? On your first guess, what's the chance of originally guessing a wrong? 2/3. So if you always change your guess, what's your chance of winning? 2/3. But if you don't change your guess, what's your chance of winning? It's just 1/3. It stays 1/3. So if you don't change your guess, your chances of winning is 1/3. If you do change your guess, your chance of winning is 2/3. Pretty cool, huh? It's a pretty neat question. Okay, so what I'd like to do now is, did you guys actually think about the checkerboard problem? So when you tried to play this game, you got angry. Yeah, what happens? I told you, play with a whiteboard, right? I distinctly remember sitting in my apartment in Budapest with a whiteboard going, because you try patterns, right? You can clear it like a row, and then you try the second one, you're like, boom! And then you try the third one, you're like, okay, I can't do this, right? It's something that you might want to use Watch to do for you. Yeah, you might want to try to design a computer program. The question is, can you do this? Can you prove you can't? Well, let's modify the game just a little bit. We're not going to modify. We're going to give some terminology, okay? And answer this question, can you win? I'm going to place the first piece right here. I'm going to introduce a concept here called the board value. The The board value is always going to be 1. So the first piece is valued at 1. When you split it into 2 pieces, what are each of those pieces going to be valued? Yeah, so 1/2 and... If I split either one of those, what are the pieces going to become? So we had 1/2, and this one will become maybe 1/4 and... The value of the board is always what? What's the total value of the board? It's always 1, because anytime you split one piece, you get half and half. Is there any way to create new value? No. Is there any way to delete value? No. So you're always going to have how much? 1. So can you keep on splitting this as many times as you want? Yeah, this is the same game, except that each piece is worth a certain amount. So I'm just going to fill these in. Now, this isn't a valid game, because can you ever fill in all of them? No, you can't. But this one's always going to be worth 1. This one's always going to be worth 1/2. This is always going to be worth 1/4. Do you see how much these pieces are worth? Each diagonal band. So this is going to be 1 what? 1/16. So all of these are going to be... Do you agree with that? So if I were to... I'm just saying what these spaces are worth. It doesn't matter how you get there, but if a piece is there, how much is it worth? 1/2, 1/4, 1/8, 1/16. Is there any way for this piece to be worth something other than 1/16? No, it's always going to be worth 1/16. Are you okay with that? Okay, so let's think about this for a second. We want to know, can you clear out that space? So I'm going to try something. Let's say we filled in all of these spaces. Everything outside the stairs. So if we fill that in, this one would be 1/32, this would be 1/64, 1/32, 1/32, 1/32, 1/32. But what's this one worth right here? Oh, it's worth what? What's the one next to it worth? 1/128. It keeps on halving, right? So could you fill in all the values in here if you wanted to? You can fill in as many as you want. Okay. I need to introduce a new concept to you. It's the idea of an infinite series. I can't prove it because we haven't done limits yet. But here's a really fun idea. If I did 1 plus 1/2 plus 1/4 plus 1/8, and I add up an infinite number of those, what does that equal? What do you think it equals? 1 plus 1/2 plus 1/4 plus 1/8? It does equal 2. It does equal 2. What happens if instead I started at 1/2? Equals 1. What happens if it's at 1/4? It's 1/8. It's 1/2. What about 1/8 plus 1/16? What happens? That's equal to 1/4. I'm not asking you to understand why, but are you okay with believing that? If you go halfway somewhere and then halfway, what are you going to get infinitely close to all the way there? 1. So what does that mean here? Well, let's look at this column right here. What's 1/16 plus 1/32 plus 1/64 plus 1/128? If I add up 1/16 plus 1/32 plus 1/64, what does that column add up to? What? If it starts at an 1/8, what's it equal? 1/4. So if it starts at a 16th, what does it equal? 1/8, exactly. What do all of these columns equal right here? They're all the same, right? Do you agree with that? So they all equal what at the top here? 1/8, 1/8, 1/8, 1/8, and... Okay, let's change it a little bit up. What does, if you add up 1/32 plus 1/16 plus, 1/32 plus 1/64 plus 1/28, what do you get? 1 what? 16th, right. What does this one equal right here? 1/32, and what's the next one going to be? 1. Okay. Let's do a little bit more addition here. If I add those together, what do I get? How many eighths do I have right there? I have 5/8 of them. Yeah. Now, if I keep on adding, what's the next one going to be right here? It's 1 what? 120. If I add up these right here, what are they going to equal? 1/16 plus 1/32 plus 1/64. What does that equal? 1/8. What's 5/8 plus 1/8? 6/8, which is what? 3/4, right? What did we just add up? We just add up the added value of everything out here. What's the problem? It's not equal to 1. The value of what? The whole area outside the, we'll call it the stairs. What's the value of the outside the stairs? Is 3/4, which is less than 1. So, there must be how much value inside? Inside, yeah.
Josh.
So can you evacuate that? So is there any way to get rid of it all? We just added. Oh, I missed all that? Okay, well, the 4 doors, you got it. 4 doors instead of 3. 1 prize, 1 gets open. What are your chances of winning if you always change your guess? 1B, I did not grade because I didn't actually get to that specific topic. I would like you to try to figure out the proper answer. There's a way to check to see if things are inverses that I did not go over that you should be able to find. And the third part of your homework for tonight, is to correct your Unit 4 test. That's the last part of your homework for tonight.